Our topic for today, we are going to look at Chemistry 1501. We are going to be balancing redox reaction in basic solution. This is lesson 103. Let us start. This is our first example for today. If we have enough time, we are going to look at more than one example of this type of question. Now, this question will come in two ways. It's either the question would say balance this in acidic condition or basic condition. So at the moment we are busy with basic condition because before you can balance the redox reaction in basic condition, we need to first balance it in acidic condition. So we are actually covering two questions at the time. If you know how to balance in basic, you should know how to balance in acidic. Now, normally, how do I approach this question? I normally use steps so that it will be simple for you. Let us look at steps how to balance. The first step that we need to do, we need to separate, to split the equation into half reactions. So looking at this equation, you can see that this reactant goes hand in hand with this product since it contains a common element. So the first half reaction that we are going to have, it will be like this. Let me actually write it here. Then we can also see that this one goes hand in hand with this one. So we have NO3 minus to give us N2O4. So this is the first step. We split the half reaction. Now the second step that we need to do, we need to introduce, or let me say, we need to balance the number of atoms using H2O and H+. But we also use our common balancing method. In this case, you can see that TE, it has one atom both sides, so it is balanced. Now we can see that oxygen is an element that we don't have on the reactant side. So we need to balance it using H2O, since H2O molecule contains oxygen atom. Now we need to look at the number of oxygen atoms we have here. Since we have 3 number of atoms, it means that we are going to add not just one water molecule, but 3 of them. Remember that we are trying to balance oxygen atom. So in this case, if we add this, we have 3 oxygen atoms on the left hand side. So you can see this is balanced, then oxygen is also balanced, but introducing this H2O molecule, we can see that we have a new element in our equation, which is H, hydrogen. So we need to go back to the product side and balance our hydrogen atom by introducing it using hydrogen ion instead of hydrogen. Now we check, it's 3 multiplied by 2, we have 6 of them, so we are going to put 6 here. We need to do the same thing to the second equation, but we are not done with the first equation. Let us go to our next step. Next step, we are going to balance the charges using electrons. To explain this, let us separate this equation using a new page. Now let us look at this. We are done balancing the atoms. We have 1, 1. We have 3 of oxygen, 3 of oxygen. We have 6 of hydrogen, 6 of hydrogen. Now we need to balance the charges. Now since we don't have any plus minus or any ions on the reactant side, it means that the overall charge of the reactants is 0. Looking at our product side, you can see that we have this 2 and then we have this 1. Now let us go ahead and calculate the overall charge. So the overall charge is 6 multiplied by this 1. We have 6 positive charges, and then minus this minus 2, we are going to get 4. So it means the net charge on the right hand side is 4 plus. So we need to balance the charges. We must have equal charges both sides. So in order to neutralize 4, we need to add electrons on the right hand side. Remember that we want to obtain the 0. We want to obtain the lowest charge. So electrons, remember that are negatively charged. So if we introduce electrons on the negative, on the right hand side, we are going to neutralize this 4. So we are going to put 4 electrons this side. So this 4 minus this, or let me say this 4 positive charge plus this 4 negative charge, they will result into 0. So you can see from here, our first equation is balanced. Number of the charges are equal. Number of atoms are also equal. So we need to do the very same thing to our second equation. We can go ahead and pause the video and work out this second equation. Now looking at our second equation, the first thing that we need to take note of, before we introduce, let us look at whether our elements are balanced besides oxygen. We look at oxygen, we have 3, 4, but it's okay because we are going to balance it using water molecule. Then we look at nitrogen, we have 1, then we have 2 here. So we need to balance this first. How can we balance? We can put 2 here. So we have 2 nitrogen, 2 nitrogen. We look at oxygen on the left hand side, we have 6 of them. It's 2 multiplied by 3. Then this side we have 4. Now from here we can check which side to balance. Since we have more number of oxygen this side, it means that we must balance on the right hand side by introducing H2O. Now you can see that we have 5 of them, we need 6 of them. We can put 2 here. So 2 multiplied by 1, it's 2, plus 4, it's 6. Then 2 multiplied by 2, you can see that we have 4 hydrogen atoms on the right hand side. Let us introduce those hydrogen atoms. Then from here, let us look at the charges. Are they balanced? The same as the first equation. On the right hand side, we can see that we don't have any plus minus, so it means the overall charge is 0. Then let us look at the left hand side. We have this negative and this positive. For the negative, it will be 2 multiplied by 1. It means we have 2 negatives. Then for the positive, we have 4 multiplied by 1. We have 4 positives. So 4 minus 2, it will give us 2 plus. So the overall charge on the left hand side is 2 plus. So in this case, we need to add our electrons on the left hand side. And then we can go ahead and update our first equation. We had 4 electrons. Now in this case, we need to add our electrons on the left hand side. And you should take note that it's impossible to have the number of electrons on the same side from both of these equations. If our first equation, the number of electrons are on the product side, the number of electrons on the second equation will be on the reactant side. If you find that the number of electrons are on the left hand side, the reactant side from the first equation, our second equation, the number of electrons must be on the product side. So in this case, we have 2 electrons. Since the overall is 2 plus, we need to put 2 minus in order to neutralize. Now these two equations are balanced in terms of charges and atoms. Now our next step, what we need to do, we need to compare this number of electrons. We need to compare this. In this case, we can see that 2 multiplied by 2 will give us this. The main aim is to make the number of electrons to be the same. So in this case, we can multiply the second equation by 2 so that we can obtain 4. So this whole equation we are going to multiply by 2. We are going to get 2 multiplied by 2 and 3. We are going to get 4 and 3 minus, and then 2 multiplied by this, we are going to get 8. Then 2 multiplied by this, we are going to get 4. You can see that now our electrons are the same. Then 2 multiplied by this, we're going to get 2N2O4 plus 2 multiplied by this, we're going to get 4H2O. So this is the new equation that we're going to use with this one. Now since the number of electrons are the same, oh no, we didn't update our nodes for the sake of writing. Number 4, we make sure that electrons are the same. That is step number 4. Let us go ahead to step number 5. Step number 5, we cancel out the number of electrons. Since they are the same, this will get rid of this. Remember, we are using these two equations. Then the next step that we need to do, we need to write, we take the sum of reactants for each equation and also take the sum of product for each equation. This is from the first equation plus this, it's actually this. Then from here, we also take the products. Remember, we no longer have this. Oh no. Remember that we're using our new equation, which is this one. So I actually made a mistake here. Oh no, everything is correct. We can continue from here. So we have this, which is 2N2O4 plus 4H2O. Just to double check. So everything is correct now. Now going back to our nodes, we are step number 5. We take the sum of reactants and products for both of our equations. That's what we just did. If the question was saying a balance under acidic condition, this would be our final answer. But since the question says balance under basic condition, we need to continue. Now, the reason why this reaction is under acidic is because of this. Remember that for a solution to be acidic, it determines by the H plus. So we can see that we have more H plus in this equation than OH minus. So in order to balance using under basic condition, we are going to introduce OH minus. Now we compare the two. Since we have 2H plus, we have 8H plus on the reactant and 6H plus on the product. The number of OH that we are going to add, we are going to choose the side with more H plus. So we are going to add 8OH minus both sides. Then you should know that whenever we add OH minus with H plus, our product will always be water. And when we add 2OH minus and 2H plus, we are going to form 2H2O. When we add 100 OH minus and 100 H plus, we are going to have 100 H2O. Now let us talk about this. Let's say we are adding 4 OH minus and 2H plus. We should know that 2 of OH will react completely with this 2H plus to form 2H2O, and then the excess, it will be 2OH minus. That is what is left here, unreacted. Then if we have 5OH minus plus 4H plus, we are going to get 4H2O molecules plus OH minus. I hope you can see what we're doing here. Now suppose we have 2OH minus reacting with 4H plus, we are going to get 2H2O plus 2H plus in excess. So this is what we must apply in our equation. You can see that here we have 8OH, we have 8H plus, we are going to have the sum of, the product of 8H2O. Then in this case we have 6H plus and then 8OH minus, then you are going to have 6H2O plus 2OH. That's how we are going to form our water molecule. Now let's go ahead and continue. We have Te plus 3H2O plus 4NO3 minus, then this 8OH minus reacting with this will give us 8H2O. Then we have TeO3 2 minus plus 6 of this will react with this, then we're going to have 6H2O and then 2OH in excess plus 2N2O4. I'll just write it here, plus 4H2O. So in this case, let us look at the like terms. We have 3H2O and 8H2O. So we are going to have Te3 plus 8 is 11 H2O plus 4NO3 minus. We do the same thing on the right hand side. We have 6H2O and 4H2O, so we are going to have a total of 10H2O plus 2OH minus plus 2N2O4. Then from here, let us update our nodes. We add OH minus to each, let me say, to both sides. You can add by saying to react with that H plus. Then our last step, we need to subtract water molecule. We subtract water molecule by the least number of water molecule. In this case, we have 10 and 11. So we are going to subtract water molecule using the least number. So we are going to subtract both sides by 10 H2O. Since 10 and 11, 10 is the least number. Then we are going to get Te 11 minus 10 is H2O plus 4NO3 . Ten minus 10, we are going to have 0 plus 2OH minus plus 2N2O4. So you can see that our equation compared to this one, it has OH, more of OH minus. So this is basic. So this is how we balance under basic condition. Our next lesson video will be based on the question that I'm about to post here. So by the end of this lesson video, you will have a question where you'll be given an equation that you should balance in basic condition. And then the next lesson video, we are going to be looking at the solution to that question. That's it for this lesson video. This is Fahula SJ. Thank you very much.